All right, well, welcome. We're going to take a look at states of matter today. When we talk about states of matter, we're talking about solids, liquids, gas. There are other states of matter such as plasma and a few others on the way on the cold end. But for us, solid, liquid, and gas for the most part. And we're going to talk about them on a molecular basis. You know, how are the molecules in a solid different from those in a liquid, from those in a gas, because that's really what determines how the solids, liquids, and gases behave. So to start with, when we talk about changes in states of matter, like I say, from a solid to a liquid or liquid to gas, the molecules themselves don't change. It's the same substance. It's a physical change. So if we have these water molecules, it could be locked into place as a solid, okay? And then as we go to a liquid, they get a little bit more movement, and then we go to a gas, and they're bouncing around all over the place. But they're still water molecules. It's still the same substance. So this is a physical change. In a solid, we find that they're packed in tight like this, and they're not sitting still. They're kind of wiggling in place. You can kind of hear the rattling going on. They're just sitting there wiggling in place. Not sitting still, but they can't change from one spot to another. You can see that this one can't move and come up over here, and this one over here come over to here. They're just sitting there kind of vibrating, sitting in place. If we were to draw it out, it would end up looking like this. You have the solid, you have the particles, they could be molecules or atoms, depends on the substance, and they're sitting there wiggling in place. We said that they have a definite volume and a definite shape. So this pin, when I move it from one container to the next or one spot to the next, it doesn't take up more space or less space. The volume stays the same, and the shape doesn't change. It's not like it's a pin now. When I put it on the desk, it becomes an elephant. It stays a pin. The volume and the shape stay the same. They're defined. They're definite. Okay, that's a solid. When we look at liquids, such as the liquid within this beaker. Liquids, the molecules are in there, and they're still close to each other, but they can slide by each other. They can move on by each other. Okay, so if we were to draw it out, it would end up looking something like this, where you have the particles, and now they can move on by each other, not just wiggling in place. They can change location. This can go from here to up there, and that one down over to here. So that if we were to look at it here, you know, it would look something more like, throw one red one in there, so you can have one to watch to see. Now that they can move around, and maybe it's in the front now, but as they wiggle, it's moving more towards the middle, and this might not be the best example because there's not quite enough freedom in there, but it can move from one spot to the next. They can move by each other in the liquid. They're still in tight. The effect this ends up having is that if I have a liquid, let's say in this graduated cylinder, and I pour it into this beaker, there's not going to be more of it. The volume's not going to change, but the shape can change. Okay, it goes from being this shape to being this shape. Solids don't do that. Liquids can. So you don't get more of it. It's not like I got a cup in here and I got 10 cups in here. You get the same amount, but the shape that it takes on can change. Gases, on the other hand, such as the gas that's in this vial here, the particles in there are zooming all over the place, back and forth and bouncing off each other and the sides of the container, boom, 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 just all over. And if I were to open this up, the gas that was in here now can make its way on out and eventually fill up, go across the whole room. Okay, so gases don't have a defined shape or volume. So it could be contained within this little container, and then minutes, or it depends on the temperature, later it could be going across the whole room. So the volume, you can take up more space, and the shape can change. Both of them can change. And if we were to draw it out, it ends up looking something like this. So here's the gas, and the particles are zooming around all over the place. A lot of space between them. So we have gas, liquids, and solids. And the shape and the volume as to whether it can change or not varies from one to the next, and what the particles are doing can also change. Okay?